In the past version or the past part, in part one of this series, I said I would go over examples. However, I'm not going to. I think that there are plenty of resources out there, especially from Microsoft, with regards to SQL Server, that will give you a better understanding of OLAP data modeling. And I have gone through enough of the theory for you to sort of get an understanding of it. So, however, now in this lecture, I will go over some things I've learned in order to hopefully make your experience developing a data mart or a data warehouse easier. The reality of things is that you can't really make a data mart without understanding the data. And you can't understand the flaws in the data without working with the data. Oftentimes, people that have been using a system for years even don't understand the shortcomings of the data because it works for what they need it to do. However, the gaps when analyzing it haven't been realized, or the processes that have been put in place in order to analyze that data have allowed for a certain amount of flexibility so that actual analysis isn't super accurate, but over time, the rules and the actual assumptions made behind that analysis have been forgotten. But when you take that same data and apply it to different scenarios, the actual problems and gaps between reality and deviation from reality will expand. And when building a data mart, especially for financial systems, this can't be allowed. And for any system, I think that the more accuracy the data has, the better your analysis will be because you can make more certain assumptions, unless you're predicting things. The existing models might already have errors in it, like I said. So you might have Excel model in place. You might have a SAS model in place. But in order to compensate and build out those models, in the past, people made assumptions because the data wasn't perfect. But those assumptions were forgotten because for some reason they weren't documented. The documentation was lost. The people moved on to a different role. Various reasons. However, oftentimes what happens is that the reasons behind certain decisions have been forgotten. And since the IT industry is new, I personally think that there is a problem just waiting to happen in the future as a lot of these people that built these systems start to circulate out of the flow. So we're going to start seeing more and more of these gaps where you have a new set of programmers coming in that have to deal with these old problems, but they don't. But because these assumptions haven't been documented and stuff, they're going to have to relearn all the reasons behind these decisions, and as a result, it's going to increase number one, the development time for rebuilding systems based off those systems. Two, actually having to deal with those systems if you don't want to get rid of something that already works and replace it with a newer system. Three, modifying newer systems in order to have the same functionality as those older systems because you don't know the reasons behind certain rules. They have been forgotten because as code grows, it can get massive. I'm talking about millions of lines where it's not even possible to read over it and understand it. With smaller applications that have been modularized, you can look over it if you're a programmer that has looked through a lot of code. But in a lot of cases, some programmers, not all, just might not be used to that. Three, not all data is useful for a data warehouse. One of the things about data warehouses is that you need the accuracy of the data is extremely important. I mean, I can't stress this enough because as the data is used for various analyses, the issues with the data will increase if data has an issue and it's used for analysis, and the more processing it goes through, that data could, those errors can grow exponentially as those reports are used, and used as source processes over time. Yeah, so those are three key concepts. There are more, but I'm not going to get into that since this is just an introduction, not a holy grail. So now they're in the industry. There's also new concepts like data lakes. Data lakes are basically like data warehouses, except they allow for you to introduce unstructured data. And so you have more raw data that might be inaccurate in your repository. However, you can use that in order to do like machine learning and stuff. Because just because data is inaccurate doesn't mean it's not useful. All right. So sometimes perfection, reaching perfection or that pinnacle of perfection is very difficult. So you don't want to do it because some people might not need the perfect data in order to do processing with. So these data lakes exist. I haven't worked with the data lake before, so I don't know that much about it. I haven't learned about it that much. I've watched a few YouTube videos which are very vague, so I don't understand about it. But you can go and learn more about it. I have heard of a concept also called data swamps, which is what a data lake could evolve into when the data just becomes way too useless, and it's just not useful for analysis because it's become so untrustworthy. Data warehouses, on the other hand, you've broken up your system into different dimensions. The data has been cleansed. It's trusted. So any analysis that you do on it, you can rely on. And any issues after a while will be due to reporting issues, not the data warehouse once it's been stabilized. So there are two states that I'd like to talk about later on versus unstable versus stable, but for now I'll put that aside. And then there's NoSQL databases, which is a new, well, not really new anymore, but basically it's unstructured data. So you don't have tables and stuff in it, and it serves another purpose, but I'm not going to get into that because I haven't worked with that for big data. I have worked with it for like backends of websites and stuff, but everything serves a purpose. So, yeah. I find that it's easier to use data warehouses for analysis because the data is trusted. Anyways, so for roles revisited, another thing I've found in the industry is separation of duties get in the way. So if you have business analysis, QA, and all those different roles, oftentimes people's personalities and the power hierarchies could actually act as a impediment to project progress because sometimes you just need data, and if you have someone that's getting you the data that doesn't actually understand the systems and their knowledge base isn't solidified, they actually act as an impediment and slow down progress. And once project progress is slowed down, the tools will people will say things like the tools suck and stuff when they don't really. If you're working with SQL and you have a proper data mart, the actual turnover time for a report should be weeks, if they, or even days, if a person understands the actual data warehouse. The majority of time is spent on learning and dealing with issues caused by people that don't know what they're doing or don't understand the downstream repercussions of what they're doing. And that's why there's so many ETL problems, because a lot of these systems out there weren't built for integration. They were built to do what they were supposed to do. But when it comes to integration, there are a lot of complexities involved because of, not because that they're bad systems, it's just that these gaps aren't acceptable for doing detailed analysis. But I'll get more into that later. So as I said, people can get in the way of development, and consolidation of roles often offers massive benefits and speed. So if you take a person that's extremely driven and you upgrade their knowledge bases with the relevant knowledge, and I mean high quality knowledge, not just learn on your own and stuff. If you give them a structured program which teaches them right and teaches them the tools that they have to use well, one, you're not going to find overly extravagant solutions for something that's actually simple to solve, which often happens in the development world. People tend to overcomplicate a process in order to go from point A from point B. So they'll go from point A to point B to point A.1 to A.2 to A.3, though, and then finally get to B. But in reality, there are simple solutions, and the simplest solution should always be chosen. Management hierarchies are found to get in the way because a lot of times there are people that have ulterior motives or delusional thoughts that might make them not want the project to get done. And they might take certain steps to sabotage or deviate people from taking a proper approach to solving a solution. Oftentimes it's best to communicate directly with the customer if you can handle that, or get someone that's very trusted to deal with the communications. Also, as I said before, web applications and websites weren't built with integration in mind. So if you have the opportunity to rapidly build out a website with the constraints you need, and you can push constraints to those websites, because if you're working with multiple departments, sometimes it's difficult to make sure that everyone follows the actual rules that you need to be specified in order to make the data in the data repository or data warehouse useful, and make sure it's clean. And often the source systems get changed. So if you have a way to harden the form inputs from a central department and push it out, and all requests go through you, of course the people that deal with those requests should have quick turnover time. So if anyone doesn't, you get rid of them and replace them with someone that's more capable. I hate to say it, but otherwise, oftentimes it's people that get in the way. And then you should be able to more quickly build out integrated systems that are that have highly accurate data that will be extremely useful, because accuracy is key here for data integration. So I went into other subjects that I didn't mean to go into. However, let's continue for now. Okay, so processes revisited. I don't think QA should occur in parallel with development. It should only occur after a feasible product is created. Otherwise, it could actually get in the way, because when people have too many ulterior targets, they actually will fight to have their objectives met, and it could actually deviate from getting the functionality in there. So if QA finds bugs while you're developing that you would have found with yourself, they're going to attack the trust. And not just attack the trust, they're going to complain to management. Management's going to attack the trust because they don't know better, right? That should be left till later on, and you should have someone that isn't a complainer that could actually identify the issues. They'll ask the right questions in order to deal with issues in the data, which you're going to encounter, because no data is inherently perfect, because issues that have been overseen, or not noticed will arise as you're doing more complex analysis of the data that you won't be able to detect easily, because they're logical flaws, not necessarily data flaws. And even the data might have breaks in it, will cause problems while you're breaking it apart that you didn't notice before, which you need to find out about later on. OLTP design principle should be used for initially replacing processes, because building a data mart or analytical database is harder. And a lot of times these processes in Excel sheets and from other websites and stuff, they weren't actually as accurate and decisions were made in order to give you what you need before, without a need for that accuracy, and that information was flowing in from department to department. So, using OLTP design principles for automating a process and replacing it can offer speed benefits as well as reducing costs. And at the same time, you could document the process while doing that, and ask the right and free up the time of the people that are doing those processes in order to document the process and identify issues. That will be useful information for when you are developing an OLAP system. The reason being because oftentimes with these systems there is no documentation, and everyone has that are conducting these processes has that information in their head, which is another reason why OLAP or data warehouse design is taking a lot longer than it should. Initial OLAP design should be done by the actual consumers of the data, because they're going to understand that data best, or consumers of the process. So they'll be able to identify the issues with the data and address them, or tell you what they are, rather than you having to train QA people that don't really work with the data and won't be able to actually understand those issues ahead of time. So this gets back to my stable and unstable states of OLAPs. So I think that or data marts should be broken up into two states as they're being developed, but they have information that is useful. They'll be in an unstable state, especially as the source systems issues are being identified. The reason for this is because there's going to be issues with the data, but that doesn't mean the data is not useful, right? You could still use that data. And as the issues are identified, it'll get more and more stabler until that data could be trusted. But initially, when you're dealing with data and the data is not really understood, there are going to be issues with it. But that isn't a reason to suddenly think that data marts are useless, right? I think, and this is my own idea, but I think that data marts should be designed as nodes by developers that are working in concert with each department in order to discover and record data issues. Initially, this is after the OLTPs have been designed, because unless you're working in that environment, you're not going to really be able to identify the issues in that department which are unique to that department, that have gone unsaid and uncommunicated. So as a result, once this information has been identified, the data mart designers could work together in order to consolidate those designs and into a single massive data repository that could be 100% trusted and cleaned. OLAP should only contain data that's 100% trusted and cleaned, which goes back to my initial theory. A lot of times, what I'm seeing is that in the data warehouse and data mart industry, is that since there's no certification or process of screening them out, and the hiring agents only seem to be hiring agents, they don't actually know how to program or anything. These are the people that a lot of employers are going to in order to get people that they need for filling certain roles. In addition to this, what's happening is that they're recirculating people, because different companies have different standards and different acceptability levels of how the designs are done. And what's happening is that these people with different levels of knowledge are circulating, and they're actually introducing design flaws into these systems and simply not collaborating and consolidating their knowledge base. And as a result, it's causing problem for one, integration, two, design principles, and many other things. So those issues are actually causing delays in the development process, gaps and inability to listen by the developers, or interest or lack of respect of understanding these principles. I don't think with development, since it's a relatively new thing, that experience, if you know the tools, the proper tools well, I don't think experience is much of a benefit, because I think that regardless if you go into that environment and you're encountering the issues, every issue is unique to that department, and the amount and even experienced developers seem to have problems with automating these systems because they're not listening in a lot of cases. And the key thing is listening and flexibility. Anyways, I'll get back to that later. So I just ranted and complained a bit, but issues should be checked for. You should have some key issues. You can't check for everything, but every integration node between these processes, when it's an OLTP system, you should check for key issues that people usually check for manually. That way, if the source process changes for some reason or another because of decisions within the department and they make a mistake, you're going to catch them downstream. And you could send them back. With OLAP, once you got an OLAP in place, you should actually limit the amount of layers. And from that data warehouse, you should have data or ODSs, in which are basically smaller versions of the data warehouse that only have information needed by different departments in order to give them a smaller subset of data, one, and also make it less confusing, two, and also allow them to do their reporting and get their analysis from a trusted source. The data warehouse should be an endpoint and source for reports and ODSs, not a node like OLTPs, for a process-based design. Because when you have multiple layers, what happens is that it makes it difficult to trace back an issue over the different departments and stuff if an issue does occur. All developers coming in and developing these systems should have their knowledge sets standardized and tested in order to reduce issues and issue occurrences, blame politics, and it'll also make experience have less relevance. In a lot of cases with significantly big organizations, they're not making progress in this. They are making progress, however, it's not rapid. It takes years, and it's there are a lot of excuses made, and you don't know. And if you're a manager and you don't have knowledge in this field, what's going to happen is that you're gonna believe the guy that has the best communication skills rather than the guy that knows the most. So as a result, what I think has to happen is that it's worth investing in these people's education, the guys that are going to put in the time in order to isolate these issues, not the people that go and work 9 to 5 or make excuses or aren't going to investigate this information on their own. If you investigate and tailor high quality information to people that'll actually put in the time and put in the work, you're going to get your system a lot faster. Initially, I thought you could train everybody, but now after having thought about it and having worked in the industry for a while, I think that 9 to 5 developers just aren't good enough. What you want is the people that'll are willing to work like from morning to night continuously and know how to do it right. Because if you know how to do it right and you know the tools well, a week job could become an hour job because you're not going to take roundabout ways to get from point A to point B. Furthermore, this will reduce DBA tasks, DevOps tasks, and simplify debugging. Because if you train all these people that are working on these systems ahead of time, they're going to be able to isolate the sources of the systems. They'll be able to automate a lot more of their tasks. There are certain considerations that can be made in the architecture of the system in order to compensate for these things ahead of time. Everything should be documented. All the developers should document their own work. I was a developer, and I found that a lot of developers don't. And they hire people that are not developers in order to do documentation, when in reality, these people are going to take months to do that documentation because they're starting from point zero. If I documented a system that I knew, I could finish off the documentation in less than a day. I've done 50 pages of documentation because I have a template for documenting my work, and it was easy. But when documenting other people's systems, the complexity increases exponentially because you don't know those small tidbits of information that the guy that made it did. So developers have to develop their own work, and it doesn't have to be perfect. It just has to be a starting point, and then other people can go over it and improve on it. Source systems can change. You need to check for potential changes at the integration layers and at integration nodes. I already said that the layer should be limited while pulling data into data warehouses to make tracebacks of issues easier. If you're going to trace an issue, use Profiler or something like that, and it should be easy. Well, not easy. It'll just help you isolate where it's coming from. And yeah, if you know how to deal with front end websites, that makes it even easier because then you can look at the different um, code layers as well. But sometimes that's not always possible because these days there are people that are solely database developers, data warehouse developers, web developers. But in the past, if you go back in time, there wasn't a separation of duties like that. Furthermore, even the coding principles have changed over time. So if you go into older applications, you'll see that it was less structured. The code was a little bit more of a mess. But if you dealt with that, it's not as hard to deal with code that's a bit less organized. I've worked in one organization that got code from different developers back in the day, and every single this was for a front end company, and every single application or person that was writing the JavaScript wrote it differently. They had their own style, which I found quite interesting. However, I do think standardizing the knowledge bases and the coding styles will help exponentially because there are a lot of people that have worked in the industry that think that they know a lot, but they don't really understand the tools and the architectures behind it. Not everyone. There are good people out there, and there are high quality individuals, but because of the hiring process and the lack of standardization of knowledge sets, which should be taught to people, this isn't happening. And as a result, because the managers can't deal with this, the core problem that's occurring, and no one in between wants to deal with it because they're more interested in bringing in cash and solving the core problems and bringing in more profit and automating things because I think that what they're doing is creating more work for themselves unnecessarily, and then they're putting in more overtime and they're complaining about it. When in reality, you don't have to put in more overtime or do all these things. In reality, you could eliminate all those costs and that overtime by having a proper knowledge set, having the proper people working on those tasks, and doing things in a different way. But the educational systems are inherently flawed. But I'll get into that later. Okay, so I had another key point that could actually speed up your development of a data mart exponentially that I don't really see in any other lectures online because I scan over lessons in various subjects periodically in order to quench my thirst for knowledge. But anyways, while you're developing a data mart, if possible, especially when working with Microsoft tools, which makes this possible because developing a data mart and integrating systems, if done right, is trivial work. You want to make the data mart, the report designer, and the data mart designer be the same person initially, or the core person. And what you want to do is make the data mart design fluid in parallel with report requests. Because what you'll notice is that based on report requests that require that data initially, especially during the unstable state, is that certain things don't work in or certain relationships or separation of data doesn't work. So you'll need redundancy in certain places that'll offer extreme speed benefits. So if you are the developer of the data mart and it isn't in a stable state, meaning it isn't a production or a trusted source, but it does have relevant data, but you can make modifications on the fly without those process constraints in place. What you can do is you can actually change the data mart design rapidly and compensate for this in the actual report requests. Initially, when developing, making architecture fluid in the beginning and updating your data models or ER diagrams this way will actually help you a lot because separation of duties increases complexity exponentially. So having people that have their skill sets consolidated and are able to do that will offer you useful data visualization at a much quicker rate. So yeah, I'm throwing this into the lecture. Note that it isn't a part of the lecture initially, so I'm actually editing the video, so it might seem a bit choppy. So yep. So issues, so data gaps in the systems. There are data gaps that go unnoticed. For example, in Active Directory, if you're using that as a source, what a lot of people don't understand is that the hierarchies, you have a management field. If you open up the program and you have the option to actually, for an employee, you could actually put in a manager. However, that manager could be empty. And as a result, what could happen is that you can actually have gaps in the data. Not always the case, but oftentimes. If you have it from the beginning, you could probably deal with it, but oftentimes you're going to get a subset of the data from Active Directory, and the older data won't be used. So what will happen is that from day one, you're going to have people in the management hierarchy, or the position hierarchy, or the org unit hierarchy that are missing. There are gaps there. And if you were to do a roll up on that data, you're going to be missing entire trees of people. It's not just Active Directory. There are other most systems that I've worked with have had gaps like that. So you should build your websites if possible in order to deal with that. But that's an ideal solution. Oftentimes you'll have to find workaround systems or integration of different data sources in order to deal with that. Dealing with older systems, you're dealing with more dirty data because they had less field constraints and stuff because they didn't compensate for things that relational databases require. Or if you're dealing with unstructured data sources like NoSQL and stuff, that problem might occur too. But these data sets have purposes for different things. You could deal with them in different scenarios. Changing systems, so then people might swap out one system for another based on a sales pitch without actually understanding the intricacies of that system because no one really understood it. This will introduce new issues because new systems are going to have data gaps that you're not aware of, so you have to use them critically. Never trust data. You have to always look at it critically and watch the system because you might not have a problem for a while, but then something might show up out of nowhere. Always use websites or applications that screen the data severely rather than Excel sheets which people put in information on manually, because this is going to increase the complexity of the ETL process exponentially. The time that's needed to build a website by someone that knows how to build a website is significantly less than what it'll take for you to build the ETL process to clean that data. Furthermore, you want to deal with these data issues at the source. The further down you deal with a data issue, the harder it is to deal with it. Ideally, you want to deal with it on the form. So you can have server-side checks or client-side checks in the JavaScript. With newer technologies, screening the data on the forms is easier. The hiring process in the education system is flawed because the universities and the colleges, what they're doing is trying to bring in money and a minimum amount of cash. The hiring process, you have hiring managers that can't program. And as a result, they're dealing with references, and these different companies are going to have different standards. And the developers at those companies or the people at those companies might make people happy there. However, these developers come to a new company and they're not willing to learn the standards of the new company, and they develop and will introduce a new set of problems. The managers don't understand how to code. That's going to introduce complexity because they're the ones that are making the decisions. And if you make decisions based on development without understanding the hardships associated with it, you could actually increase the amount of work exponentially rather than choosing an easier way. And established developers, because the technology industry is relatively new, standards have been changing as people learn more. And if you don't want to change the way, or you have worked over time or learn new ways to do what you're doing, you're going to create a lot of work out of a task that actually isn't that much work. A lot of times people that are established or senior aren't willing to learn new things or go back to school because they're comfortable. But then there's the alternate scenario where people are actually interested in learning and interested in progress. So that's why I said it's vital to isolate these people that are willing to go that route. And if you make a team of them, you have us, a group of people that could do the work of 1,000 men, versus 1,000 men that'll do the work of one driven person. The lack of documentation, lack of knowledge flow, a lot of times what's happening is that people aren't spreading the knowledge, and this is going to cause downstream issues. There are solutions to this. It's just a matter of knowing the issues and addressing them. But yeah, so continue to learn and continue to make changes and make smart decisions, and your data warehouse experience should be made a lot easier. And also know the difficulties associated with it, and document the issues and complexities of source systems. Because when developing an analysis database, oftentimes the process is everything, the approach you take. And theory and reality is very different from theory. So you have to be flexible in your approaches and not solid. Anyways, that's enough for now. Maybe I'll make another blurb about this later. But yeah, I hope you enjoyed. Later.